Welcome. Before jumping into the first page of the Chapter 8 exam practice, I just brought up our roadmap here for Chapter 8. So please use this as a reference. Hopefully it will be helpful for you. So just kind of a quick rundown here of our roadmap. So we'll be conducting hypothesis tests of a population mean mu or a population proportion p. And regardless of the method that we use, traditional method or p-value method, the writing of the conclusion will be the same based on your decision. So we have the traditional method, which uses the test value or test statistic location relative to the critical region to make the decision of the test. And then we also have alternatively the p-value method of hypothesis testing, which uses the size of the p-value relative to the size of the significance level alpha to make the decision of the test. All right, so we'll dive in here, and please again refer to the roadmap for some guidance if you need it. And let's give these a try. So number one, suppose that the critical values for a two-tail hypothesis test are z equals plus or minus 2.58. Which of the following test values leads to the decision reject H0, reject the null hypothesis? So I'm going to draw a picture here. So even though a sketch might not be asked for on an exam, having the sketch is certainly helpful in order to choose the correct answer. So I'm going to do that here. So we're dealing with z-scores in this case. So I'm just going to label that z. So 0 in the center. And then I'm going to draw my critical regions in red. So two-tail test. So we don't have to get these perfectly to scale. We're just trying to figure out where are the critical regions. So for a two-tail test, we have two critical regions, one to the left in the left tail and one in the right tail. So in a two-tail test, two critical regions, and that is our setup. I'm just going to add here as well, we don't need it for this question, but the areas of the critical region are alpha in total. So with a two-tail test, half of that alpha on either side. All right, and they'd like to know which test values lead us to reject H0. And we know that we are going to reject H0 anytime our test value falls in the critical region, also called the rejection region. So then we'll just look at these graphically and see where we are. So a test value of negative 0.97, that would not be in the critical region. I'll just label this not the critical region. All right, so that one, we would not reject H0. And negative 3.01, yes, that one is. So that one would be into that left tail, that red shaded alpha over 2 area. So that puts us in the critical region. So we would reject H0. And then we'll just eliminate these just to make sure. So 2.37 would not make it into the critical region and 1.37 would not. So that is our only value in the critical region. And then we reject H0. All right, let's take a look at number 2. So suppose the critical value for a right tail test. So we have a right tail test. We're still dealing with our z-scores here. So I'm just going to put my z there, 0 in the center. And then let's draw the critical value. Again, not worrying about to scale, but it's a positive number. So I know it's to the right of 0. And if it's a right tail test, we have a critical region just on the right. That area to the right would be alpha. And then the question now is, which of these test values leads to the decision fail to reject H0? So again, we only reject H0 if our test value is in the critical region. And otherwise, if we're not in the critical region, we do not reject H0. All right, so let's check it out. So 0.97 I think we have our answer already. 0.97 as a test value would not make it into the critical region. So we would not reject H0. Let's just make sure we're correct here with the others. So 3.01, that would be in the critical region. 2.37 also in the critical region. 1.77 also in the critical region. So that's the only test value that would lead to the decision to fail to reject H0. All right, so that's a couple examples of traditional method of hypothesis testing. We use the critical value and the test value location. All right, let's take a look at number 3. So suppose the p-value of a test is 0.0834. Which of the following significance levels leads to the decision reject H0? All right, so I'd like to write my p-values as percentages. So I'm just going to write that as 8.34%. And I know I reject the null when the p-value is low. So when the p-value is low, the null must go. So I know I'm going to reject the null if the p-value is less than or equal to our alpha. All right, so I'm again just going to write percent. So 8% is not less than 1%. 8% is not less than 2%. 8% is not less than 5%, but 8% will be less than 10%. So our p-value is lower than our alpha only for this choice of alpha. All right, number 4. For a study on a new toy, a company found that for a random sample of 60 children, the mean attention span when playing with the toy was 13.5 minutes, with standard deviation 4.6 minutes. For a test of the claim, so we're looking for a claim here, a claim that the mean attention span of children playing with this toy is greater than 11 minutes. Which of the following is the correct alternative hypothesis? So my suggestion is not to look at the choices, just write the answer yourself and then see if your answer is available. So the claim is that the mean, so mu, the population mean, greater than would be the greater than sign, greater than 11 minutes. So our alternative hypothesis, so it can't have a p in it, we're not doing proportions. And notice down here, it can't have, a hypothesis can't have a sample mean. So the sample mean is something that we know. We don't hypothesize about it. Hypothesis testing is always about parameters, population parameters. So that one's out. And then finally, I think we have our answer, mu greater than 11. I'm just going to make a note here that 13.5, that was for N, for those 60 children, that was the sample mean. And again, that's not what we're doing the hypothesis test of. So we always want mu or proportions would be P. All right, number 5. In a random sample of 40 residents, 18 were homeowners. For a test of the claim, I'm going to highlight again, looking for that claim. The claim is that less than 25% of residents are homeowners. Which of the following is the correct alternative hypothesis? All right, so the claim here is about a percentage of proportion. So we know that we're going to cross out anything to do here with means. We're not studying means. So less than 25%. So I prefer if we say the word proportion. So for test of a claim that the proportion is less than 25%, but we do know it's a proportion because it says percent. All right, so not that one. So we're looking for less than 25%. Now, just a comment here. This one does have a P correctly for proportion, but that says 25, not 25%. So that can't be correct. If it had said, just going to make a note here, if it had said P less than 25%, that would be correct. But 25 and 25% are very different things. So the correct answer is here. 25% written in decimal is 0.25. So that would be correct. This would be as well if that was available to us. Okay, number 6. A left-tail test of a population mean is conducted using a critical value of negative 1.65, and the test value based on the sample data comes out to be negative 1.02. Which of the following statements is correct? All right, so I am again going to draw a sketch here so I know what's going on. I'm going to label my critical region first. So critical value, left-tail test. So I just throw it anywhere just to have a picture going here, but I do know it's left of center. So anywhere left of center. So there's a critical value. So critical region, left-tail test is to the left. And then they give me a test value of negative 1.02. So that would be not in the critical region. So my test value is not in the critical region. And when you're not in the critical region, you do not reject the null hypothesis. Okay, and then we end this page just on some reminders when you're writing your hypotheses here. So provide 2 reasons why the following is not a valid alternative hypothesis. So one reason we've already talked about, X bar there is not allowed. So only parameters, so only population parameters. And in our case, in chapter 8, that will be mu or P are allowed. I'm having trouble writing here, are allowed in hypotheses. And then the other problem with it is it says less than or equal to, and that's not allowed. So we require less than or greater than or not equal to in H1, the alternative hypothesis. So less than or equal to, not allowed. All right, so 2 reasons that hypothesis is not written correctly. And then number 8 here, 2 reasons why this is not valid. So similarly, no p hats, right? So just a reminder that p hat equals your sample proportion. And again, my writing is horrible, sample proportion. So remember, sample information, that's called a statistic. So statistics are not allowed in hypotheses. We need to have parameters. All right, so p hat, statistic, not allowed. And I'm just having us think about these. You're not going to have to write this explanation out. I just need you to make sure that you know that that would not be valid. So p hat is not allowed. And then again, oh, sorry, I almost had trouble reading it. So last one was H1, the alternative. This one is the null hypothesis. So in the null hypothesis, we are not allowed to have a not equal to. So H naught, the null hypothesis, must contain equality. Right, so not equal to, not allowed. All right, I feel like I went a little bit slowly there through this page, but hopefully that page is good. And